Hello everyone and welcome back to Integral Calculus. This is section 3, the first video in section 3. Okay, if you've not gone through the first few videos, I'll put the link in the description below so that you go through them, because going through them is going to serve you as a good foundation for what we are going to do in this video. Now in this video we are looking at different forms of integration. I'm going to be looking at two forms. That's what we are going to look at in this section, but this is going to be the first form. The first form is when you have a fraction. There are some fractions you're going to see. The first thing that should come to your mind should be this form that we are going to look at in this video. Okay, so when you have a fraction like this, where when you differentiate the denominator, that's what this is saying, that when you differentiate the denominator, are you going to get the numerator? Now if I differentiate this, differentiating this is going to give me f prime of x. Now whenever you differentiate the denominator, if you're getting a numerator, then your result should just be log of the denominator. So you're excluding is more like you're saying, okay, I'm doing without the numerator, let me just have my result to be the log of the denominator. That's what your result should be. But this is usually expressed in another form. It's expressed in the form ln of f of x. Now ln of f of x, and as usual there's going to be a plus c. Here also there's going to be a plus c, because we're integrating, and after integrating, a plus c should be inclusive. So that's what we have according to the first form. Now we've seen this, an example of this, in the previous videos, but we took it as a standard. So what do I mean? This is the first example we are going to look at. We know that if we integrate 1 over x, our result is going to be ln x. But what's the result for ln x? The result is basically ln x, because when you differentiate x, if I differentiate x, what I'm going to get will be 1. Since when I differentiate x I'm going to get 1, then I'm doing without the denominator, and I'm saying my result should be ln of the denominator. But I can see the numerator is gone, I'm looking at the log of the denominator, then plus c. That's why I said we've seen this example before. So this is the reason we basically have our result to be ln x. The second example we are going to look at is when you have this expression. Now in this expression, if I differentiate this denominator, I'm going to get the numerator, because differentiating x squared will give you 2x, differentiating x will give us 1. Since differentiating this is giving us the numerator, my result becomes ln of the denominator. They are as simple as this. Let's see a couple more examples. This is the same thing. If I differentiate x cubed, I'm going to get 3x squared. Differentiate 3x and 2x squared, I'm going to get 4x as my result. But when you differentiate 1, your result is a 0. And since your result is a 0, you know to that you can do without putting the plus 0. So our result finally becomes ln of the denominator, then plus c as usual. Simple enough, right? Okay, let's see one more example in this video. So if I want to differentiate, or rather integrate, cot x. So for you to differentiate, integrate cot x rather, you need to work with some standard. You should know that cot x, okay, whenever you have cot x, don't mind my writing, cot x is basically equal to cos x all over sine x. Okay, is equal to cot x over sine x. Since it's equal to cot x over sine x, this is a trig identity. This is not calculus. This is basically a trig identity. So if I have this as a standard, what do I do? So what I have to do is to express cot x as cos x over sine x. I've not integrated yet, take note. We've not gone through the process of integration yet. Now I have a fraction. Since I have a fraction, I can go ahead and ask those same questions. If I differentiate the denominator, will I get the numerator? And that's a yes here, because if you differentiate sine x, you're going to get cos x. For that reason, your result becomes ln of sine x, then as usual plus c. And that's it, guys, for this video. You can see that if you know this form, integration is going to be quite simple. There's actually an alternative to this form. That's if you forget this form. Now whenever you forget this form, the alternative is by using integration by substitution, which is what we are going to treat in the next section. Okay, the next section is about techniques of integration. We are going to look at integration by substitution and some other forms of integration. So that being said, as usual, guys, don't forget to subscribe to this channel if my videos are helping you in any way. Don't forget to like and also share these videos among your friends, and I'll see you guys in the next video where we're going to look at different examples still on this form of integration. These ones are quite straightforward, but is it always going to be as straightforward as this? The answer is actually no, and we are going to find out in the next video. I'll see you guys. Bye bye.